Alright, we move now to the next task, task 4. We have a composite wall that consists of two layers. Layer 1, we have the thickness of the first layer, L1, 0.06 meters. The thermal conductivity, kappa 1, 0.9 watt per mole times Kelvin. And then for layer 2, we have L2 equals 0.15 meters and thermal conductivity, kappa 2, 0.5 watt over mole times Kelvin. And then we have these heat transfer coefficients, H1 and H2. We have the values for H1 and H2. We have the indoor temperature, which is 30 Celsius degrees, and the outdoor temperature, which is 0 Celsius degrees. And we have the surface area of the wall, which is 20 meters squared. And we want to compute this heat transfer ratio, which is employed through the wall, and we need to use this formula. So basically Q is going to be in watts, and it's going to be a function of all these parameters. So Q is going to be T out minus T in, so 30 Celsius degrees minus 0 Celsius degrees over. And then you have these terms in the denominator, 1 over eta 1 times A, so 26 times the surface area of the wall is 20, plus 1 over 12 times 20, plus L1, 0.06 over kappa 1 times the surface area, alpha, which is times 20, plus L2, the thickness L2, 0.15, and then you have kappa 2 times the surface area, 0.5 times 20. Okay, so the numerator is going to be 30 Celsius degrees, and the denominator is going to be 1 over 26 times 2 is going to be 52, 520, plus 1 over 240 plus 0.06 over that's going to be 18 plus 0.15 over 1. We just write the numerator, and we have 1 over 520 which is 0.002 roughly, plus 1 over 240, which is gonna be 0.004, plus 0.06 divided by 18, (0.003) plus 0.15. So that's going to be 0.009 plus 0.15. It's going to be 188.679 watts. Okay, all I have done is using this formula this complicated formula here to find what is this heat transfer coefficient in watts. In the numerator we have the difference of temperatures, and in the denominator we have these reciprocals, 1 over eta 1 times 1 over h1 times A, which is the surface area of the wall, plus 1 over h2 times alpha. And then we have these two terms where in the numerator we have the thickness L1 and thickness L2, kappa 1 and kappa 2, some coefficients, and then alpha, which is the surface area of the wall. We plug everything in and we get a reasonable estimate for the heat transfer Q, which is 188.679 watts.